Alright, this video is on doing integrals using trigonometric substitution. So I actually want to look at this through an example. And so we're going to look at this first problem. And if you have not already, you should watch the intro to trig substitution because we talked about how to pick a trig substitution in order to get rid of a square root. So most of the time when you're doing trigonometric substitution, you're going to be using it to get rid of a square root. And so if you look at a problem like this, trig sub is an option because of the square root that's there. There are problems where you would use trig sub that don't involve square roots, but that's less common. Okay, so what we're going to do here is we're going to use trig substitution. And so looking at the square root, we're going to pick the x that we would have picked on the last video. And so based on what we were doing on the last video, we should pick 2/5 sine theta. And we do that because the 5 will cancel the 25, the 2 will make the 4 match, and this 1 minus sine squared is cosine squared. Okay, once we do that, we kind of do trig sub in 3 very large steps. And so we're going to write those on the screen, but the 3 steps, and like I said, they're not like small steps, they're pretty broad. So the first step is you pick x like you do like we did in the last video. Once you pick x, you find dx based on what x was. And so dx is like with u substitution, where it's going to be the derivative of this times d theta. And so we're going to get 2/5 cosine theta d theta, or you could think of that as dx d theta is 2/5 cosine theta and then solve for dx. But either way, we're going to pick x, we're going to find dx. Normally, but not always, normally we're going to get rid of a square root. And we're going to do that on the side. And so we're going to do the work for the square root on the bottom left of the screen. So just looking at the square root, we've got the square root of 4 minus 25x squared. That's equal to the square root of 4 minus 25 times 2/5 sine theta squared. We can square that and get 4 minus 25 times 4 over 25 sine squared theta. The 25's cancel and the 4 will factor out. And so we get 4 times 1 minus sine squared theta. That then is the square root of 4 cosine squared theta, which is 2 cosine theta. Okay, so we pick x, we find dx, we get rid of the square root, we're going to sub everything in, and we're going to simplify. All of this is a very large first step. So when we do the problem back up here, anything that is not in the square root gets replaced with what it is. So any x that's not in the square root, like the x squared at the beginning, we replace that with whatever we chose, which here was 2/5 sine theta, and it's squared in this problem. Now the entire square root gets replaced with this 2 cosine theta at the bottom of the screen. So we replace that with 2 cosine theta, and then dx gets replaced with whatever we found for dx. That in this case is 2/5 cosine theta d theta. Okay, so we picked x, we figured out what dx was, we got rid of the square root, and now we've subbed everything in. We're now going to simplify. So I'm going to pull coefficients out. So the stuff on the bottom, when you bring it out, flips. So on the bottom, we really have 4 over 25, if we look at that. And so that's going to become 25 over 4, because it was squared. The 2 on the bottom comes out as a 1/2. The 2/5 that was part of the dx stays as 2/5 because it's not in the bottom of a fraction. Remember, this is different from u substitution. So on u sub, you multiply outside by the reciprocals because you're putting something in that wasn't there to begin with. Here, you're replacing the stuff that was already there with whatever they're equal to. So the 2/5 that we're pulling out and the 2 on the bottom that we're pulling out, those are in the problem, and we're just removing them and factoring them out of the integral. Okay, also on this problem, the cosine thetas cancel, and we're going to get 1 over sine squared theta d theta. Okay, so all of that together is the first very broad step. We pick x, we find dx, we get rid of the square root, we substitute in and simplify. These problems at first especially seem like a lot, and they are a lot, but this first step, once you get good at this, is actually very straightforward, and you do the same thing every time. Unlike integration by parts in U-sub, where a lot of times you have to be pretty creative, these are very routine at the beginning. This is the same process basically every time. Okay, we simplified more or less. We can simplify the coefficients, but the second broad step is you need to figure out how to do the trig integral. So presumably at this point, the integral is going to have trig functions in it because we're using trig substitution. And so we've got to figure out how to do that. There's a variety of ways to do that. In this case, 1 over sine squared is the same as cosecant squared, which is a basic form. Sometimes the integral might involve u substitution, it might involve parts, it could be powers of sine and cosine, powers of secant and tangent, among other things. It could be impossible, in which case trig sub's not a good option, but there's a lot of different things that could happen here. This is the part of the problem, step 2, where it's not consistent. This problem that we've got on the screen is relatively straightforward because after using this identity, it's a basic form. We're also going to simplify the fractions outside, so the 2's cancel, the 5 cancels with the 25, so we get 5 over 4 outside of the integral. The integral of cosecant squared theta is negative cotangent, so we get negative 5/4 cotangent theta plus c. So that's step 2, is to do the trig integral. Okay, the problem with this answer, so we've actually done an integral now. The problem is we completely made up theta, and so we now need to somehow go back to x. So step 3, we're going to actually draw a picture in order to do that, and we're going to go back to x. And so what we're going to do to draw the picture, and we'll do this in green to kind of keep the steps separate. So step 3 is going to be in green. We're going to go back to the original substitution. So the x equals 2/5 sine theta. And we're going to solve for the trig function. So sine theta, if we solve for that, is 5x over 2. We get that just by multiplying by 5 halves on both sides, and then I reverse the equation. We're going to draw theta as an angle in the first quadrant. So we're going to say, okay, theta is an angle in the first quadrant, and there's not a guarantee that the angle's in the first quadrant, but in the next video we'll talk about why it turns out it doesn't matter. For now, we want to get this process down. So we draw theta in the first quadrant, and then we draw a triangle from the terminal side of theta to the x-axis. We draw a line to form a triangle. We label that triangle based on sine theta. So this side, if it's 5x, then the hypotenuse side would be 2. Remember that sine is either opposite over hypotenuse or the y value divided by the r value. And so we can label a triangle with the angle there, theta, where the side opposite that is 5x and the radius or the hypotenuse is 2. Once we draw the picture, we're going to then solve for the other side. So using the Pythagorean theorem, we know that a squared, if that's the side that's missing, plus 5x squared, 5x all squared, is 2 squared. So we get a squared plus 25x squared equals 4. So a squared is 4 minus 25x squared. And a is going to be the square root of 4 minus 25x squared. That should match the square root that you started with in the problem, and it does. But it's worth going through the Pythagorean theorem to make sure of that. Once we have that, now we go to the answer that we had in terms of theta and try to figure out what x is. Or figure out how to get it in terms of x. So in this case, cotangent theta is something we can get off of the diagram. Cotangent is x over y or adjacent over opposite. It's the reciprocal of tangent. So we can get that by reading the diagram. It's the x side or the adjacent side. That's 4 minus 25x squared, the square root of that, over the opposite side, which is 5x plus c. That last line is the first legitimate answer that we've had to the original integral. We're almost done. We can simplify a little bit, but aside from some simple algebraic simplification here, that's all we really can do. And so what we're going to do here is we're going to cancel the 5's and multiply straight across. So we're going to get negative square root of 4 minus 25x squared over 4x plus c because we canceled the 5's. Okay, so we need to get this process down. So we're going to go through 2 more examples in this video, and we're going to go through them a little bit more quickly, but it's important that you try them first. So try to model what we're doing on this problem, especially on number 2. Try to model what we did on number 1 as closely as possible. So pause the video, see if you can do the trig sub and go through the entire process, and then check it with me in a minute. If you don't feel comfortable doing that, watch me do the problem and then go back and do it again yourself. This is something you definitely need to practice. Once you get this down, it's not as bad as it seems, but it is something you need to practice quite a bit when we're doing these problems. Okay, so on this problem, we're going to choose for the trig substitution to be x equals 4/3, because we want to cancel the 9 and end up with 16. We're going to pick secant theta because we want to end up with secant squared theta minus 1. dx then is the derivative of that, which is 4/3 secant theta tangent theta d theta. Okay, so I'm going to go down on the bottom left and do the square root. So we're going to get rid of the square root. So we get the square root of 9x squared minus 16. That's the square root of 9 times 4/3 secant theta squared minus 16. That's going to cancel the 9 when we square that, so we get 16 secant squared theta minus 16. We're going to factor the 16 out. Secant squared minus 1 is tangent squared. And the square root of that is 4 tangent theta. Okay, so we go back to the original problem. We fill in dx on the top. So the dx on the top is 4/3 secant theta tangent theta d theta. The x squared on bottom becomes 16/9 secant squared theta, just because I went ahead and squared that. And then the square root gets replaced with 4 tangent theta. Now we simplify this. The 4/3 in the numerator comes out as 4/3. The 16/9 in the denominator becomes 9/16 when we pull it out. And the 4 in the denominator is really 1/4. The tangents cancel and one of the secants cancels. So we get 1 over secant theta d theta inside the integral. We now simplify the fractions, so we cancel the 4 and the other 4. We can cancel the 9 and the 3 and get a 3 on the top. So we get 3/16. We need to figure out how to do the integral of 1 over secant theta. In this case, that's just cosine theta d theta. The integral of cosine theta d theta is sine theta plus c. Okay, so we get it to there. We're now going to try to go back to x. So we come over to the side and we go to the original trig substitution. So x equals 4/3 secant theta. we solve for the trig function. So secant theta is 3x over 4. We draw theta in the first quadrant. Secant is r over x, or hypotenuse over adjacent, which means I can label this as 3x and I can label that as 4. The other side then is the square root of 9x squared minus 16, because it's the hypotenuse squared minus the other side squared, and then we take the square root. We can read sine theta off of the diagram. Sine is y over r, or opposite over hypotenuse. And so it's 3/16 times the square root of 9x squared minus 16 over 3x plus c. We can now simplify by canceling the 3's, and we get the square root of 9x squared minus 16 over 16x plus c. And that's the answer on this problem. Again, I would recommend that you pause the video and try this problem on your own before completing the video. Real important to get practice doing this, but we're going to do this together in just a minute. Okay, so on this problem, we're going to choose for x to equal 1/5 secant theta. 1/5 because I want to cancel 25 and end up with 1. Secant theta because I know I'm going to end up with a trig function squared minus 1. We do the square root on the side. So the square root of 25x squared minus 1 can become the square root of 25 times 1/5 secant theta squared minus 1. That gets us 25 times 1 over 25 secant squared theta minus 1. The 25's cancel, so we get secant squared theta minus 1. So we get the square root of tangent squared theta, which is tangent theta. Forgot to find dx. Dx is the derivative of secant theta, so that's 1/5 secant theta tangent theta d theta. So now we sub everything in. So we get 1 over 125, third power of secant, so secant to the third, theta times the square root, but the entire square root becomes tangent theta. Dx becomes 1/5 secant theta tangent theta d theta. I'm going to pull the coefficients out. So the 1 over 125 flips. The 1/5 does not. The tangents cancel, and 1 power of secant cancels. So inside we get 1 over secant squared theta d theta. 1 over secant squared is the same as cosine squared. So when we're doing the integral here, we use half angle because this is powers of sine and cosine, where both powers are even, or the only power is even. We can then make that 1/2 integral 1 plus cosine of 2 theta d theta. And now we're going to split that into 2 integrals. So we get 25 halves integral 1 d theta plus 25 halves integral cosine 2 theta d theta. Now the integral of 1 d theta is theta. The integral of cosine 2 theta d theta is 1/2 sine 2 theta. So we get that plus c. Now we need to figure out how to go back to x. So we're going to go back to the original substitution and draw the triangle like normal. So x equals 1/5 secant theta. That means secant theta is 5x. or we can think of that as 5x over 1. So we're going to draw theta in the first quadrant. So this is theta. We're going to put 5x on the hypotenuse, or the r side. We're going to put 1 on the x side, or the adjacent side. Using the Pythagorean theorem, we get that the third side is 25x squared minus 1. Okay, so now, on the previous two examples, at this step, we've had a trig function of theta in the answer before converting back to x. When you have a trig function of just theta, that's the way you do it, is just read it right off of the triangle. When you don't, if you have a trig function of 2 theta, for instance, you want to figure out a way to get it in terms of just theta. And so the double angle formula for sine that we know from trig is that sine of 2 theta is equal to 2 sine theta cosine theta. So then we are going to replace that with its identity. And so we've got 25 halves times 1/2 times 2 sine theta cosine theta plus c. We do that because sine theta and cosine theta can be obtained just from the diagram. All right, so let's simplify that part, and then we'll talk about what happens with theta. So here, the 2's cancel, so we get 25 halves. Sine theta is the square root of 25x squared minus 1 over 5x. Cosine theta is 1 over 5x. And so we get both of those off of the diagram. Theta, we use inverse trig to get. And so we go back to the trig function that we solved for. So if secant theta is 5x, theta itself in this problem can be written as the inverse secant of 5x. And so when you have theta in a trig function, we deal with it like we did on the previous two problems. When you have 2 theta in a trig function, you use a double angle formula to get it in terms of just theta. If you have other expressions, we could use other identities to get it in terms of just theta inside of a trig function. When you have theta not in a trig function, you should use inverse trig. And because of what we'll talk about in the next video, it's standard to use the inverse of the trig function that we originally chose for the substitution. Meaning, if we used secant here, then use inverse secant. If we use sine, then use inverse sine. If we use tangent, then use inverse tangent. Okay, the last thing is to simplify this. So we get 25 halves inverse secant of 5x, which we won't simplify. We can cancel the 2 5's with the 25, and so we get plus the square root of 25x squared minus 1 over 2x squared, and then plus c. And so that's the answer on this problem. All right, before advancing to the next video, you should work as many problems as you have time for. So there's a worksheet with, I think, 10 problems or so and worked out solutions. And then there's a homework assignment with 4 problems. On the next video, we'll go through kind of the rationale as to why what we're doing is allowed. We won't go through it completely formally, but we'll go through the ideas as to why this is legitimate. A textbook might go through this in a little bit more detail than what we will, but not much. So anyway, I will watch that video and kind of justify this. Before watching that video, it's a good idea, or it would be important to make sure that you're comfortable with this process. All right, thanks for watching.